two-dimensional motion problem for an object rolled off a table with only a horizontal component of velocity. We have two components to our motion. We're traveling down, and we're traveling horizontally. Knowns about traveling down, we begin with actually no vertical motion. We have acceleration due to gravity, and our distance traveled in the y direction. Solving for variables in the y direction, our velocity that we maintain while striking the surface of the ground we can solve for by using the appropriate kinematic equation. Plugging in and solving. Also solving for the time required to strike the surface of the ground in the vertical direction. I'm going to use this equation. Plugging in. And solving. So now we know pretty much everything there is to know about what happens in the vertical component of motion, walking that information over to the horizontal component of motion. The only variable that we initially know about the horizontal component of motion is how far it travels horizontally once leaving the table. We don't know the amount of time required to hit the ground. We don't know how fast it's moving in the horizontal direction, or how fast it's moving just as it leaves the table, because it contains no vertical motion once leaving the table. Now, the amount of time required for it to strike the surface of the ground in the vertical direction is equal to the amount of time budget that we have to work with as we're traveling in the horizontal direction. Using a DST triangle, we can now solve for our speed, d, s, and t. We can now appropriately solve for how fast we're traveling once we leave the table.